Hello, this is AAT section 2.2 graphing, quadratics, and standard form. So we're working on graphing parabolas, and more often than not, quadratic functions are not represented in this vertex form, which is y equals a times x minus h squared plus k, but often they're in standard form, which is this form. Remember, A tells you whether it opens up or down and how narrow it is. A in this form is the same as the A in this form. The number that comes before x squared would be the same in either way. The x value of the vertex is just going to be opposite b over 2a. I've talked about that a little bit before. And once you get that x coordinate, you can plug it back into the function to find the y value. So here we're going to graph these in standard form. The other way we can do it is to complete the square. We'll do a few of those as well. So here's our A, B, and C. So our vertex opposite B over 2A would be the opposite of 6, so negative 6 over 2 times negative 3 is our A, which of course would be 1. And once we get that vertex x coordinate, we plug it back in. And we get negative 3 times 1 squared plus 6 times 1 minus 1, which is negative 3 plus 6 is 3 minus 1 is 2. So our vertex is 1, 2. Our A value is still what's in front of x squared, which is negative 3. Our axis of symmetry, remember, is x equals positive 1, because that's going to be the line that cuts it in half. And so we can still use our over and up over 1 up a, and a is negative 3, over 2 up 4 times a, and 4 times negative 3 is 12, negative 12. Write it out this way if you think you'll forget. If you go over 3, it'd be 9 times a. We're not going to use this one, but that would be negative 27 if we wanted to. Okay, so we graph our vertex, 1, 2. This is a downward facing parabola because it has that negative a value. So we're going to go over 1 down 3, 1, 2, 3 from the vertex in both directions. And our next one would be 12 over 2 up or down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And over 2, down 12 on the other side. So there is our parabola. Okay, so next one, our A value. Our B value, there's no x term, so our B value here is 0. So our B is 0 because there's no x term, and our C is 7. So opposite B over 2A would be just 0 over 2 times negative 4, which is, of course, just 0. So the x coordinate of the vertex is 0. We plug that back in, and we're going to get 0 plus 7, so 7 is our y coordinate. Our A value is negative 4. So if we do over and up, over 1 up A, over 2 up 4 times a, which is negative 16. So a vertex of 0, positive 7, 1, 2, 3, 4, 5, 6, 7, over 1 down 1, 2, 3, 4 in both directions, and next would be down 16, but I think this would work perfectly, just like this. Our axis of symmetry would be x equals 0, because that line, x equals 0, cuts the parabola in half. All right, moving along. Why don't you pause right here and try A, and then, okay, so here are the answers to this one. Our vertex, by doing opposite B over 2A, is negative 1. Plug it back in, and we get negative 4. Our A value is 1, so from negative 1, 4, we're going to go over 1 up 1, over 2 up 4 times 1. Our axis of symmetry is just x equals that x coordinate of the vertex. And I also asked here for the y-intercept. The y-intercept, remember, is always where x is 0. It's real easy to see when it's in standard form, because if this is 0 and this is 0, our y-intercept is going to be just -3. Good check to make sure you end up with that parabola at the same time. Okay, so this next one, well, one more thing on before we go on. Here, if we want the x-intercepts, the x-intercept is where y equals 0. And since that equation can be factored to x minus 1 times x plus 3, and we all know how to factor, we can set those equal to 0, and x equals 1 and x equals -3 are the x-intercepts, 1, 0, and -3, 0. So those are also handy to have. You can see they already fell on my a values, -3, 0, and 1, 0. But I can check and see those x-intercepts. So on this new parabola, it's not in standard form yet, but I can easily find the x-intercepts by setting y equal to 0. Since it's already factored, why not go ahead and do that? And we get x equals 1, set this equal to 0, because if two numbers multiply to be 0, one of them has to be 0. So if we set x plus 5 equal to 0, x is -5. So I already have 2 points, 1 and 1, 2, 3, 4, -5. So we need it in standard form to do our vertex, opposite b over 2a. So if we FOIL this out, first is x squared, outer is 5x, inner is -x, last is -5. So x squared plus 4x minus 5. Now if we do opposite b over 2a, we get -4 over 2, which is -2. So our vertex x coordinate is -2. That also helps me find that axis of symmetry. I can go ahead and put as x equals -2. Move this down a little bit. And so to find the y-coordinate, we plug it back in to find the y-coordinate. So we plug in -2, get -2 squared. So that's 4 minus 8 minus 5, which is -9. Our a value, right up here, is 1. So we start at -2, 1, 2, 3, 4, 5, 6, 7, 8, 9, over 1 up 1, over 2 up 4 times 1, 1, 2, 3, 4, and over 3 would be up 9, and that's how we get those x-intercepts that way also. Where's our y-intercept? It looks to me like it's at 1, 2, 3, 4, 5, -5, but remember the y-intercept is where x equals 0, so if we plug in x equals 0 here, we're going to get y equals 0 minus 1 times 0 plus 5, which is -1 times 5 is -5. So that checks out also. Write your y-intercept as a coordinate. So there's our parabola. Make sure when you finish, you found everything you were asked to find. We found the y-intercept, we found the axis of symmetry, we found the vertex, we also found the a value and the x-intercepts, even though we weren't asked to, so we're overachievers. Okay, so going back, we've completed the square before, but going back, here are the rules to remind you how to do it. If you have an equation in ax squared plus bx plus c form, to complete the square, you'll isolate the x squared and x terms. So we're going to start this one out by moving that 13 over to the other side. We want to get rid of that constant term, so that's the first thing we do is move that over. And then if there's a leading coefficient, meaning a number in front of the squared term, we must factor it out. So if I pull a 6 out of 6x squared and 12, I have 6 parentheses x squared plus 2x. Be super careful of negatives here. If you pull out a negative, you got to change the sign of everything in the parentheses, and we'll see one like that in a second. Okay, then to complete the square to make it a perfect square trinomial, we'll find half of our b term, b over 2, and we'll square it. So half of 2 is 1, and 1 squared is 1. So we're going to add that inside the parentheses. Well, whatever we do to one side, we have to do to the other. Well, we added in this 1, but since we added it in the parentheses, we actually added 6 times 1. So make sure you're multiplying it times that, and then multiply the same thing to the other side. So this over here is 6 times 1 as well. The perfect square trinomial, take half of the x term, square it, and place it in the box. So that's what we did here. Simplify. So we're going to now factor this right side, and factor this term is always going to be just what half of b was. So x minus 2x plus 1 factored is x minus 1 squared, and it'll always be a perfect square trinomial like that. On the left side, we have negative 13 plus 6 is negative 7. Then we want to get y alone, so we add the 7 back over, and it's in the nice vertex form. So to convert these into vertex form, we're going to start by, well, subtracting that 5 to the other side. And we're going to factor the 2 out. So we have x squared minus 2x. Okay, so we brought the 5 to the other side, get rid of the constant term, and we factor the 2 out of everything left. So that I do 2 times 2x squared is 2x squared, 2 times negative 2x is negative 4x. Then, to make it a perfect square trinomial, we take half of this b term and square it. So half of negative 2 is negative 1, and squared it is positive 1. But whatever we add to this side, we have to add to this side. But we didn't just add a 1, we put it in the parentheses. So we added 2 times 1, so we needed to add a 2 to the other side. So we have y minus 5 plus 2 equals 2, parentheses, x squared minus 2x plus 1. Well, this on the left side is just negative 3. On the right side, this is x minus 1 squared if I factored it. Two numbers that multiply to be 1 and add to be negative 2. Now if I bring that 3 back over to the right, I have it in vertex form. The vertex is 1, 3. Remember, it's the opposite sign of this. Our a value is 2, so it'd be really easy to graph now. Okay, so this one's actually a little bit easier. We're going to start by bringing that 71 over to the other side. There's no coefficient in front of x squared, just a 1, so we don't have to pull anything out, so that's nice. So we're going to take half of 16 and square it. Half of 16 is 8. Squared it is 64. And whatever we do to one side, we have to do to the other. I don't have to worry about the parentheses on this one. That's why it's a little easier. So we have y minus, so 64, that'd be 7, equals this right side. This is already a perfect square trinomial, so I can go ahead and factor it as x plus 8 squared. I need to get my y alone, so I have x minus 8 squared, then plus 7. The vertex is 8, 7. Now you can check the vertex by just doing opposite b over 2a like we did earlier, and making sure the vertex is what you think it is, and then plug it back in to get that y value. Okay, I'm going to stop right here and we'll continue this section on the next video.